Greetings and welcome, friends, boys and girls, geometry fans, logicians of all ages. We're taking a look at last night's quest, page 80, in the Big Ideas Geometry textbook. So here we go. It says, make and test a conjecture about the given quantity. Let's see, the quotient of a number and its reciprocal. All right, so let's do some experimentation here, friends. So let's see, if I've got the number 2, its reciprocal is a half. All right, if I've got the number 3, its reciprocal is a third. If I've got the number 4, its reciprocal is a quarter. Now, you might recall that dividing by a fraction is the same as multiplying by the reciprocal, right? So this is the same as 2 times the reciprocal of this reciprocal, which is 2. Which this I would argue is 4. This is going to equal the same as 3 times 3, or 3 over 1. I mean, you can throw that if you'd like. This will be 9, and this is 4 times 4 over 1, which is 16. Conjecture. Ready? Here we go. Let's see. I'm running out of space. Let's see. The quotient of a number and its reciprocal is equal to, does anyone have a theory? The quotient of a number and its reciprocal is the number squared, right? All right, makes sense to me, right? And I could even prove this in generic form. If I have x divided by 1 over x, that's going to equal x times x, which is equal to x squared. They didn't ask us to prove it, but there we go. Let's see. And I think we've already tested it, kind of in my discovery of it. So that's good enough for me. So let's see. Exercise 21. Use the law of syllogism to write a new conditional statement that follows from the pair of true statements, if possible. All right, so here we go. All right, thanks for visiting, gentlemen.
Bye, internet friends.
All right, the internet wishes you the best of luck at tournaments.
Okay.
Let's see, so statement number 1. If x is less than -2, then the absolute value of x is greater than 2. Okay, so there's 2 statements. All right, I'm just kind of hypothesis conclusioning this. Let's see, next one, this is a completely new statement. If x is greater than 2, that is not yet one of those other things, then the absolute value of x is greater than 2. I've seen that one before. That's my purple statement here. So now the question is, can I make a new statement from this using the law of syllogism, which I refer to as the transitive property of logic, that if A implies B and B implies C, then A implies C, and we can just cut out the middleman. So here we go. I actually cannot link up these statements in any way because the conclusion of this statement is not the hypothesis of that one, and the conclusion of this statement is not the hypothesis of that one. So I can't make any new conclusion. Can't use syllogism. All right, I don't even know how to spell it. S-Y-L-L-O-G-I-S-M. There we go. Right, does not apply. And the reason is because the conclusion of either statement is not equal to the hypothesis of the t'other. All right, 23. Let's see, is 23 from that same batch of instruction? It is. See if we can use the law of syllogism. Okay, here we go. If a figure is a rhombus, rhombus, then the figure is a parallelogram. Do you guys know if that's a true statement or not? Yeah, it is a true statement, yeah. Then it says, if a figure is a parallelogram, then the figure has 2 pairs of opposite sides that are parallel. So opposite sides that are parallel. Now, notice the conclusion of statement 1 is the same as the hypothesis of statement 2, So I believe I can assume that if rhombus, then opposite sides parallel. And that's what I'll write as you watch me slowly write this. I just need someone to like edit my videos and like high speed through some of this less interesting stuff. If a figure is a rhombus, then it has two pairs of opposite sides that are parallel. Yeah, that's kind of, I know, my writing. Opposite sides that are parallel. Okay. All right, last question. I haven't looked at this one long enough to know anything about it, other than that it looks like it might take some thinking. Question 45. Decide whether each conclusion is valid. Explain your reasoning. So this first batch of bullets, I'm assuming, are true statements. And now we're trying to determine, based on those truths, can I conclude A? So it says, you went camping in Wyoming. Let's see. All right. Yellowstone National Park is in Wyoming. All right. I think I believe that. You and your friend went camping at Yellowstone National Park. So I definitely went camping and at Yellowstone National Park. And Yellowstone National Park is in Wyoming. So I think A, I can say is true based on syllogism, right? Because, right, here's my hypothesis and conclusion. This conclusion is the same as that hypothesis. So therefore, if this, then Wyoming. And then also, let's see. Oh, wait a minute. Let's see. You and your friend went camping at Yellowstone National Park. Okay, yes. It also said that we did go camping. So we're good. All right, so yeah, true. Let's see. Your friend went canoeing. It says when you go camping, you go canoeing. If you go on a hike, your friend goes with you. If you go, then, it says you go on a hike. Wow. There is a 3-mile-long trail near your campsite. All right, so your friend went canoeing. Thoughts? I'm going to say false. It's possible it's true, but I cannot prove it is true with the given facts because all I know is that I went camping, I went canoeing. Yeah, no fact there. I think I'll just let my verbal explanation suffice. Let's see. C, your friend went on a hike. Let's see, it says it says I go on a hike. There, let's see, so this statement is true, which is the hypothesis of this statement. So this looks like law of detachment. And then it concludes that your friend goes with you on said hike. So I think the following is true based on detachment. All right. Let's see. And then D, you and your friend went on a hike on a 3-mile-long trail. I'm saying false. Survey says false. We don't know. There's a trail that's 3 miles long near my campsite. But you and I both know that me and my friend are playing Pokemon Go, and we were just hunting Pokemon when we're on our hike. We didn't necessarily go on that trail, right? You can't prove it. You can't prove it. So, yeah, it doesn't say that if I went on a hike that then I went on the 3-mile-long trail. Not enough evidence to conclude that. All right, well, thank you for watching, Internet friends. Have a great day.